Unit 10, Day 8, Solving Logarithmic Equations. Let's do a little bit of review first. So our first problem says solve 2e to the 2x plus 2 equals 7. So the first thing we're going to do is we're going to isolate our exponential to one side of the equation. So we have 2e to the 2x plus 2 equals 7. So I'm going to subtract 2 from each side. So 2e to the 2x equals 5. I'm going to divide both sides by 2. So e to the 2x equals 5 halves, or 2.5 if you prefer decimals. So the next thing we're going to do is take the ln of both sides. So 2x, ln of e to the 2x is just the exponent, 2x, equals the ln of 5 halves. So we'll take out our calculator. We'll take the ln of 5 divided by 2. 0.916. And that's 2x. So we're going to divide both sides by 2 to get x. .458, and then it says round to the nearest tenth. So 0.5 for number 1. Number 2, evaluate log of 100 plus log of 0.001 plus ln e, etc., etc. So in our calculator, we'll go ahead and first we'll start off taking the log of 100. 2. Log is base 10, 10 to the second power is 100. So we'll do this same operation as we go across. I'll write them all down at the end. Log of 0.001, 10 to the, oops, that was an error, 0.001, 10 to the negative third power. ln of e, well, it's e to the first power. So we'll go ahead and take the ln of that. What we should get is, of course, 1. Now we have 8 ln of e. Well, we already know what ln of e is, so that will be 8. We'll be subtracting that. And then we'll take log base 7 of the square root of 7. Well, let's put this in our conversion change of base formula. So we're going to have the log of the square root of 7 divided by the log of 7. Now we have the same base. Instead of using that log base 7, we use change of base to use just log. You could also have used ln, for example. So we'll go ahead and throw that in the calculator. We'll do log times the log of the square root of 7. We'll divide that by the log, oops, clear, square root of 7. We'll get out of our radical, and we will divide that by the log of 7. What's really happening here is we're trying to find out what power do I raise that base to, that's 7, to get the square root of 7. So if you're really familiar with your exponentials, you should know this will be 1/2. And it is. So let's go ahead and write out what we had. We had the log of 100, which is 2, plus the log of 0.001, which was negative 3, plus ln of e, which was 1, minus 8 ln of e, minus 8, plus 1/2. It's a negative. So 2 minus 3 is negative 1, plus 1 is 0, minus 8 is negative 8, plus 1/2 is negative 7.5, or 7.5, whatever you like. Given log of a equals 8, and log of b, notice these are both log, so base 10, equals 4. Find log of a divided by b. So we got to find the base. Or, not the base. The base is 10, but whatever that number is, and that number is. And then we're going to plug those in. So first, the first part is actually saying 10 to the 8 equals a. So log of a equals 8. 10 to the 8th power equals a. And then we're going to do log of b equals 4. So 10 to the 4th equals b. So now we're going to go ahead and do log of a, which is 10 to the 8th, over b, which is 10 to the 4th. 10 to the 8th divided by 10 to the 4th is, subtract our exponents, 10 to the 4th. Log base 10 of 10 to the 4th is 4. Moving on to new work. Oh, by the way, if you wanted to check your work there, we could do a was 10 to the 8th, so log of 10 to the 8th, 1, 2, 3, 4, 5, 6, 7, 8, divided by 10 to the 4th, 1, 2, 3, 4. Options to solve logarithmic functions. So the first thing we're going to do, if there is only one logarithm in the equation, we're going to isolate the logarithm. Then we're going to turn the equation into an exponent using the loop method. I'll be showing that in just a moment. Then we're going to condense the logarithms and get the same base on both sides. Then we're going to cancel the logs and equate the rest, the remaining part. And we're always going to check for extraneous solutions. So extraneous solutions would be like if the log of x equaled a negative number, that's not really possible. So first, log base 3 of x equals 3. So the loop method gives us that 3 to the 3rd power equals x. We take our 3, move it over as an exponent, and we move our x to the other side. So 3 to the 3rd equals x, so x equals 27. Does that make sense? Log base 3 of 27 is asking what power does 3 have to be raised to get 27? The answer is 3. ln, which is base e of x, equals 4. So we're going to do our loop, and we get e to the 4th equals x. Well, we can do it in the calculator, but to the nearest 100th, we will do e to the 4th. 54.598. So we go to the thousandths place. We're going to round up. That makes the 9 also round up. So we get 54.60. Third problem. Log base 4 of x plus 5 equals 3. So that means that 4 to the 3rd power equals x plus 5. 4 to the 3rd power, 4 times 4 is 16, times 4 again is 64, equals x plus 5. We'll subtract 5 from each side, so x equals 51. Why is my pen not working? 59. 6 log 2x equals 18. So this is the first one where we actually have to isolate the logarithm. So let's do that first. We'll divide both sides by 6. So log, which by the way is base 10, of 2x equals 3. So, we'll take our base, 10 to the third power equals 2x. 10 to the third power is 10 times 10 is 100, times 10 again is 1,000. So we'll divide both sides by 2, and x equals 500. The next one, 7 plus 8 ln. ln again is base e. X equals 5. So we'll subtract 7 from each side. 8 ln of x equals negative 2. We're going to take and divide each side by 8 to isolate our logarithm. So we get ln base e of x equals negative 1/4. So we're going to use our loop. So e to the negative 1/4 equals x. So e to the negative 1/4. What does that really mean? Well, you can think of it as 1 over e to the positive 1/4, but your calculator doesn't really care if you don't need to do that. So we're just going to go ahead and take e and raise it to the negative. Make sure you use your negative symbol, not your minus sign. Negative 1 divided by 4. We get 0.778. So we're going to go out to that 8 and round up 0.78. ln square root x plus 2 equals 1. Well, what is x plus 2 square root? It's really the 1/2 power. This is e. So what this is really saying, again, we're going to loop. We're going to get e to the 1 equals the square root of x plus 2. So now we're going to square both sides. The square root of x plus 2 squared is x plus 2. When I take e to the first and I square it, I multiply the exponents. This is power to a power. Multiply the exponents. So I get e squared, or e to the second power equals x plus 2. So I'll subtract 2 from each side. So x equals e to the second power minus 2. Put this in the calculator. E to the second power plus, or excuse me, e to the second power minus 2. Oh, forgot to get out of my exponent. Let me do this again. E to the x. E squared. Get out of your exponent. Minus 2. Enter. 5.389 and change. So we will round up to 5.39. E is a number, 2.7. 2.7 squared minus 2. Solve each logarithmic equation by canceling logs. Round to the nearest hundredth. Check for extraneous solutions. So first, we have log with the same base. If these two are equal, then x plus 5 equals 2x. Subtract x from each side. X equals 5. So the insides are only equal if it's the same base. So we may need to do change of base later with some of these problems. So now we have ln of something equals ln of something else, but those somethings must be equal. So we'll cancel those logs. We know that 7x minus 13 must equal 2x plus 17. We will get our x's to one side and our constants to the other. 5x equals 30, so x equals 6. By the way, checking your work, feel free. So here we're going to put 6 in for x. We'll have ln of 42 minus 13 equals ln of 12 plus 17. 42 minus 13 is 29. So the ln of 29 should equal the ln of 12 plus 17, ln of 29. Don't even need to take a log to know that those two are equal. And I'm going to resync, see if I can get my next page to come up. I'll just go ahead and write these out. So the next problem, log of x plus 5 plus log 4 equals log 72. Same base. So let's go ahead and bring these together. This will be log of, when we add the logs, multiply the insides. So we're going to have 4 times x plus 5 on the left equals log 72 on the right. So we'll multiply this together. This is log 4x plus 20 equals log 72. So 4x equals 72. So 4x equals 52. Divide both sides by 4. X equals 13. If we want to check our work, we are going to put in 13 for x. So we'll get log of 18 plus log of 4 should equal log 72. So remember, this is 10 to a power equals 18, 10 to another power equals 4, etc. So go to our calculator, log 18, 1.255 plus log 4, 1.85 should equal log 72, 1.85. Our next problem, again, I'm just going to keep writing these out. So we have 1/2 log base 7 of 25 equals log base 7, 23 minus 4x. What does this really mean? It really means that that is the exponent. So we're going to move that over the exponent. 25 to the 1/2 power is 5. So this is log base 7 of 5 equals log base 7 of 23 minus 4x. We can cancel our logs. We get 5 equals 23 minus 4x. Subtract 5 from each side, add 4x to each side just to get us a positive. So 4x equals 28, so x equals 7. I made an error somewhere. Oh, minus 5, 18. 4x equals 18. Divide each side by 4. X equals, 4 goes into 18, 4.5 times. Next problem. 2 log x minus log 4 equals 2. Well, first, we know that this means that's squared. So log x squared minus log 4 equals log 4 equals 2. So this is subtraction. When we add logs together, it means we're multiplying our numbers together, or our expressions together. When we subtract logs, that means it's division. So this is log of x squared over 4 equals 2. So now we're going to use our loop method. That means, since this is log base 10, that means 10 squared equals x squared divided by 4. 10 squared is 100. I'm going to multiply both sides by 4. That's 400 equals x squared. We'll then take the square root of each side. Square root of x squared is x. The square root of 400 is 20. That's problem number 12. We have log base 4 of x plus 2 minus log base 4 of x minus 1 equals 1. So our laws of logarithms, we'll do log base 4 of x plus 2 divided by x minus 1 equals 1. We'll do our loop method. So we know that this is going to be 4 to the first power, just 4, equals x plus 2 divided by x minus 1. Now it is an algebra problem. We'll cross multiply and solve. So x plus 2 equals 4 times x minus 1. X plus 2 equals 4x minus 4. I'll subtract x from each side and add 4 to each side. 3x equals 6, so x equals 2. And again, if we want to check our work, log base 4 of x plus 2. 2 plus 2 is 4. Minus log base 4 of 2 minus 1 is 1 equals 1. Well, log base 4 of 4 means 4 to what power equals 4? The answer is 1. Log base 4 of 1 means 4 to what power equals 1? The answer is 4 to the 0 power equals 1. Didn't even do change base in the calculator to figure that one out. So that is the end of our day 8 problems. Make sure to practice some on your own. Make sure to go back and try these rules out.